Determine whether the following series converges or diverges. The sum from 1 to infinity, n minus 1 factorial over n plus 2 squared. The sight of the factorial should make you immediately jump to the ratio test. It could be that we could figure out that this limit isn't 0, but it would be too much work. So let's just go right ahead and jump right into the ratio test. And so we have the ratio test is a look at the successive terms of the series divided, a sub n plus 1 divided by a sub n. A quick way to get to the heart of the matter is to replace all of your n's by n plus 1's where they appear at. So we create two fractions, one with n factorial in the numerator and one with n plus 3 quantity squared in the denominator. In the gaps, we put the terms from the original series that are corresponding to these guys. N minus 1 factorial underneath and n plus 2 quantity squared up top. We do each of these limits individually. Based on the size of what comes out, we can decide whether it converges or diverges. And so we will deal with this factorial by taking off one term from this n factorial and making it n times n minus 1 factorial to cancel with the n minus 1 factorial from the denominator. N plus 2 squared, n plus 3 squared, it's just going to go to 1. And so ultimately we're looking at n. As n gets big, it's going to go to infinity. And so that's definitely greater than 1. I guess we could have seen it from the beginning, but we'd have to know about growth rates. A factorial grows much faster than any polynomial. And if you have a numerator that grows faster than your denominator, then you're not going to be 0 for your limit. To be 0, you need your denominator to grow faster than your numerator. So we could have seen it there and done the test for divergence. It wasn't as bad as I thought it would be, actually. But the ratio test works well. It responds back that the series diverges.